awesome background day.
Birthday.
Square roots as irrational numbers. 6, no vocab. So, definitely, I suppose on the positive note is at least we're just doing one concept here. You can pretty much, there's 24 of them on this page, and now 24 more on this page here. So, I'm going to start with number 3. I'm just going to dive right into it, and I will tell you what you need as we move along here, and you'll figure this out. So, if you can believe it, this could be simplified. Square root of 128. You're probably thinking, well, how if I go on here, and if I go 128, I get that answer. But this could be simplified, and in the math world, this is something that needs to be simplified. How do you simplify it? What does that look like? So I'm going to build a factor tree. That's what I'm going to do here. So, you know, it divides by 4, 2. I don't know what it all divides by off the top of my head, but I know it divides by 2. And again, you have your calculator. You can certainly just go 128 up, 64. Okay. You can certainly do that there if it helps you there. 64 breaks down further to, I'll just keep going this way, 32 and 2. I'll call this 16 and 2, call that 8 and 2, call that 4 and 2, and call that 2 and 2. So once you break it down the tree here, this one, most of them aren't going to be powers of 2 all the way to the end, but this one happens to be. So normally won't be quite this long. But what I'm going to want to do next is write it in expanded form, except I'm going to write it this way. I'm going to put it inside the square root box because it is the square root of 128, right? I could say that the square root of 28 is the same thing as the square root of 2 times 1, 2, 3, 4, 5, 6, 7 times. It just is, right? Yep, well, 1, 2, 3, 4, 5, 6, 7. 6, 7. 4, 7. 4, 7.
In 20 years?
20 years. 20 years. 20 years. It'll be 6, 7.
I'm gonna message you on Facebook in like 20 years.
20 years. 20 years. It's coming. So, anyway, would you agree that the square root of 128 is the same thing as the square root of 2 times 2 times 2 times 2 times 2 times 2? Yeah. 2 to the 7th power. 2, yx, 7, up. There it is, 120. Oh, now we agree, right? So, what do we do with all this and why does it matter? What we're looking for is pairs. Now, I'm just going to start with this. Let's just go back to 4, all right? Because we know 4 is 2 and 2. If I said the square root of 2 times 2 equals 4, you would agree with that, right? Right? But you could also say 2 times 2 is 2 squared, right? Because I'm just multiplying it. So I could say the square root of 4 is the same thing as the square root of 2 squared, right? You guys probably know enough about squares and square roots to realize they are complete opposites of each other. If I add 1 to something and subtract 1, it cancels itself out. But squares and square roots essentially cancel each other out. So this square here and this square root just cancel each other out. What am I left with for an answer? The square root of 4. We already know the answer is 2, but you can see how this looks if I break it down this way. It is 2 times 2. It is 2 squared. A square and a square root cancel each other all out. All I'm left with then is just a 2, right? So take that same concept here. These two 2's could cancel each other out, right? So the square root of 4 is 2. So I could say I have a 2 out here. And these 2's, same deal. They cancel each other out, right? The square root of 4 is 2, so I have another 2 out here. And these two also cancel each other out. So I have a third 2 out here. Now this 2 doesn't cancel itself out. There's no 2 to combine it with here. So what do I have? Think of this as your remainder in a way, right? So what do I have left over? A square root of 2. But what was I able to cancel and bring outside of the box? I was able to bring out 3 2's. 2 times 2 is 4. 4 times 2 is 8. The square root of 128 simplified, we would say 8 root 2. 8 root 2.
That was so confusing.
I'll do a couple. But, so watch. But 128, right? There's 128, right? If I take the square root of 2, multiply it times 8, it's the exact same number, right? See it? 128 square root of 2 times 8. So this would be the simplified answer to root 128. We'll do a couple of them here, but what we're looking for is, again, we're going to build our trees. We want to write them in expanded form, and we're looking for these pairs here that I can combine and essentially move them outside of the box. Think, again, there'll be more numbers, but just think of this one thing here. The square root of 4 is 2 times 2, 2 squared. But we know the square root of 4 is 2, but how does it actually work? The square root and the square sign cancel each other out, and all I'm left with is a 2 outside the box. Right? Try number 5. Negative root 500. So the first thing you're going to want to do, build trees. Break it down to prime form. And then write it all out in expanded form. That's your first goal here. See if you can do that. And then I'll do mine, and then we'll talk about what we got to do next. Again, we may take different paths, but we should all end up with the same bottom line. Personally, I'm just going to do 105. And I'm going to do 20 and 5, and then 5 and 4, and 2 and 2. So 2 times 2 times 5 times 5 times 5. Did we all get that? Yeah? Colin, still working on it? This is how I did my tree. So this is the same as root 500. 5 times 5 times 5, 125 times 4 is 500. All 500 is there. So where do I see a pair? 2 and 2. All right. So 2 times 2, just think about just this part. What's the square root of 2 times 2?
2.
It's 2. Like a 2, not inside the square root box. That's gone. I've dealt with that. That is 2. What about this? Do I see a couple 5s? So I can do that. So 5 times 5 is? 5 times 5 is?
25.
The square root of 25 is? 5. So then, again, bringing it out here. It's always multiplying. But that's gone. What about this?
Still in there.
Right, and it's going to stay in there because there's nothing else. It's prime. There's nothing I can do with it there, right? So that's part of my answer. What's going over here? 10. And then, of course, it was negative, so we'll throw a negative, but negative 10 root 5 would be the answer here. And again, you can check them. You just go 500 square root. What is it? Oh, 22.36, blah, blah, blah. And then go 5 square root times 10. What is that? Oh, 22.36, blah, blah, blah. So, I mean, you can check these without too much stress in your life here.
Wait.
Oh, yeah, there it is.
It's somewhere there. 6, 7.
It's 23.36067,977. Okay. Right. 6, 7. So But you can check it really doesn't take a ton of time. I mean, it's kind of a wonky process. We will definitely practice some more of them here, but this is all it is. It's just trying to understand how this works here and just being able to pull out as much whole number as I can. So basically what I'm telling you here is your simplified square root answers will always be a prime number. Always, right? You'll always have a prime number here. Because if it's like 4 or 9 or, or 10, you could break that down farther, right? It could be factored farther. So, okay. So why don't we try number 7?
6 or 7?
You can do 6 homework 7 right now. 6 homework 7 no. 6. So root 720. Some of them you have to definitely think about a little bit.
Oh yeah, can we do 10?
5, 6, 7.
It's not funny when you do it. It's like,
Wow. So, what one of you, if you can give me the expanded form answer. I'm gonna work on it a bit myself. That's it. Yep. So, any of you 3 fine people have expanded form?
3 times 3 times 2 times 2 times 2 times 5. I think I might have added an extra 2, but
There's 4 twos.
There's actually 4 twos, Faith. Not 3. You gave us 3.
Obviously.
2 times 2, 2 times 2 times 3 times 3 times 5. There's 7 numbers. Here's the tree right here.
Okay, I think I did it.
that looks like a camel.
Yeah, yeah. This one, no matter what path you took, it's going to take a while to get to the bottom of this one. So now, there it is. We got it all in this form.
Oh, I
Now,
know
see
what I
if you
did.
can turn it into the final answer.
I did it.
Yeah, I'll give them a second.
Can I answer it though?
Yes, but
Yeah.
give them just a second. See if they get it.
They're not gonna.
But yep. Again, first you got to get the tree right.
What's page 6, 7 in our book? It's the practice chapter 2 test.
I was thinking maybe it'll be a test.
It is.
Oh, I'm looking in the hardcover. The hardcover book, it's 3-2 in your workbook. Okay.
Workbook is.
All right,
Chapter 2.
Sam, what's the answer?
12 and root 5.
12 root 5
Did
is
it.
correct. You got it?
Yeah.
Right, so these two combined, boom. I mean, you can cross them off this way. These combine, or however you want to keep track of it, boom. These combine, boom, 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 boom. What do I have over there? 2 times 2 times 3. There's 12. This, still in the square root box. There's nowhere for it to go. There's nothing to combine it to. I cannot simplify this any further. This is as simple as it's going to get. Let's see.
Let's do 10.
Let's
Let's do
try-
10. Please.
Oh, we can't do- Is there another one that meets the criteria somewhere in the lesson? Try number 17.
29 is 7, 6.
We'll do a few in the back here in a little bit.
We gotta do 29. It's 7,
Root
6.
464.
Dog, I don't know these. Oh wait, I can just.
Everybody's rubric is on the floor.
That's mine, I just dropped it.
I see this.
But put it in the list.
Please don't do that.
Put it in the recycle.
Is 29 a prime number?
Is it?
Is 67 a prime number?
Actually,
I think
It's
it's
29
a prime number.
I don't remember. No, it's
Is it?
No, it is.
2 and 232. 2 and 116. 2 and 58. 2 and 29. I live in a world where 29 is prime.
same, bro.
And again, you can represent this however it helps you. I mean, I'm not saying you have to write it, whatever. I mean, obviously, you know you need this chain of numbers here for the next step. So, whatever you, however and whatever you want to process it to get to this type of answer. So, let's see. Does anybody think they know what the answer to
Yeah.
17 is? Sam did got one already. Colin?
4 root 29.
4 root 29 is correct.
What is root 29?
Did you get that one, Faith?
Wonder if root 29 is a 6, 7, or I bet it does.
There's a 2. Oh, another 2 right over there. I got 2 times 2 on the outside. There's my 4. Root 29 is prime. It won't go any farther than that. Let's look at a couple on the backside. So, generally the same principle going on here. You need to simplify both sides. You'll notice there's a number of perfect squares in here. Damien, don't need the balloon at the second here. Some of them have perfect squares. A lot of them have perfect squares. There's some whole numbers. There's a few different scenarios here. 27. Root 72 over 49. So I could write this the same way. If I wrote it this way, this is the same thing, basically here. I mean, I could divide 79 by 49. We know we're going to get some sort of improper or irrational number type answer. 79 divided by 49 is irrational, and the square root of that is certainly going to be irrational. But there it is, right there. Instead, though, that's not a simplified way. I'm not looking for some decimal answer here. I don't want you to write 1.27 as the answer. That would be terrible. It's not what we're doing. We're simplifying, not converting to a rational number, not the directions.
That's a 72,
So,
not a 79.
rounded.
No, top of the 70.
Right, 79, right.
Basically.
So on the bottom, that should be pretty easy to resolve right off the bat. That is 7, and that can just stay there. On the top, though, root 79. You need to ask yourself, can that be, or it's 72. Sorry. There we go, 72. So the question is, can root 72 be simplified? Simplify. Go. What do I have on top? I got a 7 on bottom. What do I got on top?
6 root 2.
Not quite. Or wait, yes.
I do it?
I thought it was 8 root 2. Yeah, you did. Colin got it. 6 root 2. 9, 8, 3, 3, 4, 2, 2, 2, 2, 2. So 3 times 3, 2, 2, 2. So the 2 and the 2, that's out. The 3 and the 3, that's out. What's still in? This, the one that can't be paired up with anything there. So there's the 3's combining up to move. When they combine up, they get to move outside the box. That's what they want to do. So when they combine up, they were in the box, and now they're outside of the box. So that's what they desire. If they can combine, they will. If they can't, then they can't. Think of it like your remainder. But 6 root 2. So then on top, I have 6 root 2. On the bottom, I have 7. This can't be I mean, if I had to simplify the fraction part, and you will have a couple, then we'd simplify 6/7.
6/7.
See, snuck up on you there. You're looking for it, and then all of a sudden it just happens for you. But yes, you would still need to simplify the whole number fraction parts in these here, right? This, of course, 6/7 can't be simplified at all, right? Greatest common factor is 1. But if I had 6/8, if, for example, this was my answer, I'm just saying theoretically, if this was my answer here, this needs to be simplified further, because this is the fraction 6/8, which could be turned into 3/4. That would be simplified. So be on the lookout for your whole number parts and your fractions here. If you can simplify the fraction, simplify the fraction. This has nothing to do with the square root. Unless somehow we run into a situation like you would get an answer like this, which I don't know if it happens, but if that would happen, well then these would just cancel each other out. Kind of like the pi situation we looked in the homework, right? And here, so then, and these would turn into 3/4, and then this would just be 6√2 over 8√2 is actually just 3/4 in the end, simplified. Yes? Try, not that one, that one's stupid.
That's not nice, Mr.
Stupid.
Wilson.
33.
Sure, try 33. Do a couple of these here. So whether they write it with 2, this is the radical sign, by the way. If we didn't say it, the radical sign, this number inside is radicand. But sometimes they write it with 1 radical sign, sometimes but both are the same thing. This and this are the same thing. They just switch around how they represent it from time to time, but they are one and the same. So don't be thrown off when you see it both ways.
What the? Oh. This one's weird, but I think I got it.
Yeah.
17 and
So, anybody got the answer?
Is it square root 34 over 4?
Yes, it is.
2. Wow.
Because when I try and break down 34 prime, I can't combine 17. This is prime. I can't go any further with it, right? The root 34 is as simple as that one's going to get. Yeah, so you'll see that scenario too. Yep, just square root, but yeah, I mean, you'll run into these types of things. Okay, I want to try that one's not fun. 39. 39. That one's fun. I think it is.
I'm scared to know what the definition of fun is.
I think you guys are picking this up here. So.
Okay. I think we have different definitions of fun.
Yeah, I think so.
No. 37, I mean 361. 19 times 19. If you can do this, you can do it all. You're a superstar.
Okay, think, I got it. That's all.
Yeah, this one's top shelf. I mean, if you can do this, then the rest of them are cake.
I don't like this
Oh,
Well, 72 we did back in 27. It was 6 root 2,
I might have an answer.
right? We did 27 not that
Yeah,
long
I
ago.
remembered that.
So
6
there's
sevens.
that.
6 sevens.
200 we have not done. 102, 50 and 2, 25 and 2, 5 and 5. 2, 2, 2, 5, 5.
Oh, I
A
forgot.
2, a 5. We got 10 root 2.
3 tens.
Huh?
3 tens.
Yes.
Right. So the first step is, did you get here?
Yes.
Yes.
Yeah? Then, did you see the simplifyings that can be happen?
I knew it needed to be something.
Right, because these root 2's, they just cancel each other out because they're the same, just like the pi. And then what do I have left over here? 6 tenths. Well, I could divide both of those by 2, just like I simplify any normal fraction. That's all I have left at this point, just a fraction answer, 6 tenths. And then, yeah, I would simplify 6 tenths. We always simplify fractions. That was good. Last one, I think. You guys feel all right about it?
Yeah.
You guys seem pretty good about it. I think so, unless you want to do another one.
No, thank you.
Okay, try 40, what do you want, 41 or 43? Pick one. 43? All right.
46 or 7. Good 43. Okay.
Root 18 over 900. I will pull a stick at random. If that person gets it correct, we done. But if they
Hang on a minute,
don't, then
let
we
us,
better try 41.
Work it out.
Right.
2, okay, 900.
You can just give me the final answer. You stick recipient, you.
Just wait.
Odds are not in your favor of having your stick picked, though.
Oh, yeah.
One of you will get picked.
I want it to be me because I'm just so not sure.
You feel like this lesson can be over with? Sam feels he can end the lesson if he's pulled.
I'm locked in.
Faith feels locked into something.
You should show your glasses to the camera.
Mr. Belcher.
It's gonna cut up. Oh, he's upside down.
I don't know if I can go.
Oh, that's an unfortunate pose for me.
Am I even in the camera?
Go up a bit. Go up a bit. Go up a bit. Go up a bit.
Up a little
Little
more.
more, little
Up a
more.
little more.
A little bit more.
Face reveal.
Yeah.
First face reveal.
Eh, a face reveal. Right, that is true. I don't know if my face is really in any of these here. They had to see this on the camera. We had to. Right. Okay. Oh yes. Okay. Right.
Okay, I'm locked.
Principal
I'm
is
locked.
just looking at the room here.
He looks really confused.
Colin is still in progress to this cop.
Colin.
I can't even pull a stick until.
I'm locked in. I'm locked in. I'm locked in.
Please eject.
3 of you finished at very different times. So this
Okay.
Yeah.
All
they-
right,
they
Colin.
sort of need it.
Here we go, 43. So first, I'll get the official answer, but then I got to hear from the other two at the poll. But only one answer really counts. Faith,
I don't know if you can do this, but I simplified it. So I got 1 times the square root of 2 over 10.
square root 2 over 10.
Base like times 1.
Well, anything times 1 is itself.
Yeah.
Okay. Sam, what do you think?
I got that.
Sam agrees. Colin?
Yeah, I didn't get that.
Colin did not get that. The correct answer is, which one are we doing here? 43. Ding, 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 ding.
Wait,
Did you get either of the numbers? Did you get root 2 on top? Oh, yeah.
I did get root 2 on top, and I got 10 on the bottom. I had a 3 for some reason on the top.
900. What is that? 300 times 3. 100 times 3. 50 and 2. 25 and 2. 5 and 5. Look at that. 2, 2, 3, 3, 5, 5.
Yeah, it
I
was
thought it was not, originally I had 9, and 9,
And then the top, I had 3, 3, and 2. So
I had 9 root
3.
2 over 30, and then I simplified it to 3 root 2 over 10.
Is that? 3 root 2. 9 times 2. So then what did we have here?
Well, yeah, it was 3.
So on the
root
bottom,
2 over
2
30.
times 2. So 2
9
times
root
3
2.
times 5. 6 times 5 is
Oh, I
30
did
on the
3 times
bottom.
3.
So you'd end up with 3 root 2 on top and a 30 on the bottom.
Okay, so yes, I just did
We're done now.
the
And
wrong.
then this turns into that.
I did 3 times.
Anything times 1 is itself. And there we go. Okay.
Whatever. I was.
You feel good about it?
Yeah,
I have the-
subscribe.
So Monday, you guys will have a very boring lesson. Very boring. The real number system. Another vocab heavy day. Video me will take care of it. I'm going to help them with quiz prep and do a quiz on Monday. So
Like and subscribe.
I need to review equations with them. But your lesson's not
In
exciting.
20 years, you'll be 67.
It's similar to 2.5 in a sense with the excitement level. So you'll classify numbers again, and that's Monday. Okay.